Hey, what's up guys? This is Krishna here. Welcome to another exciting tutorial. Today we're going to do Houdini Softbody tearing. Now before I go into it, thank you very much for subscribing to my channel, sharing, commenting, liking, and also purchasing my files. I really appreciate it. Thank you very much. I'm going to leave the project files link in the description. Please support me by purchasing those files, and those files will contain the tutorial files and the original file. Okay, so let's jump right into it. Let's create a sphere, and I'm just going to change this to Vellum meat, I guess. Change this to polygon, increase the frequency to 10. It's going to zoom out a little. And I'm going to transform this up by 3. Okay, that looks pretty good. I'm going to create a group called base. Now, I don't think we need this, but I'm creating it anyways. Right. And I'm going to put in an RBD material fracture. For now, I'm going to leave everything at default. Okay. And I'm going to put in an RBD exploded view just to visualize what's going on. Yeah, I think that looks pretty good. We're going to put in an sample, and connect it to the first output. I'm not going to change anything. I'm not going to make packed geometry. I'm just going to create name attribute. I believe it's already done in the material fracture. We'll see. We won't use it if we don't need it. All right. Let me just pull this. Okay, good. I'm going to create for each named primitive. So if I click here, you can see there are 25 pieces. So if I disable this, we still have 25 pieces. So we will just leave assemble disabled for now. Okay, right. I'm going to go out and remove this to the side. I'm going to create another sphere. And in fact, I'm going to delete that. And I'm going to just control click on the sphere here. So it creates this. And I'm going to go into Vellum and let's click on tetrahedral softbody. Okay, so it's created these 2 additional nodes here. If I go into the sphere object, I'm going to use this side. Sphere object, you can see it's created these nodes here for us. Okay, all of this. So let's go back into Vellum meat. Let me just expand this a little. I'm going to copy the first 3: poly reduce, remesh, and tet confirm. Copy them, paste them here, and drop them in here. So the idea is that if I check on single pass, every piece that comes in, let me just disable that. Every piece that comes in gets reduced, remeshed, and tet confirmed. Okay, that's good. And I'm going to copy this tetrahedral constraints and paste it at the bottom, outside of for each node. Okay, there you go. So let me uncheck single pass. So it goes through everything, and right here is a whole lot. All right, perfect. So that looks good. I'm going to copy these 2 here as well, which is the geo and constraints. Good. Now, if you notice that it's created an auto dot network, okay? Now, I'm going to show you both ways. Basically, first of all, I'm going to create a Vellum solver, and let's use that for now. And then I will create a .NET as well. Okay, and I'll explain the reason shortly. So I'm connecting Geo into the first to the Vellum solver and constraints in the second one. All right, so that's looking good. I'll enable this. That's fine. And enable ground position temporarily. And let's see what happens. Okay, it's falling. Okay, so it's falling and it's getting like really squished. So that tells me one thing. That is, we need to increase the stiffness. So currently it's set at 0.01. I want to change it to e to the power of 10. Okay, and let's run it again. Okay, that looks a lot better. All right, good. Okay, so I'm going to create a box on the side here. Template it and transform. So let's move it up by 3. Okay, and I'm going to push it onto this side. We're going to use this to pull the sphere. Okay, looks good. How about negative 1.5? No, that's slightly outside. 1.4 is pretty good. And I'm just going to disable the sim for now. Go to 12, and I'm going to leave it at 1.4, and to 24 I'm going to change it to, let's say, -2, and then at 36 I'm going to bring it to back to -1. Okay, and then at where did I say? Yes, that's right. So at 48, I'll bring it back to -2. At 72, I'll take it up to -4. Okay, so I'll show you what's going on right now. Right. So before I do that, I'm just going to save this, and I will change this to, I don't know, 120, I guess. All right, that looks good. So if you look at this box here, okay, so that's the action I'm looking for. 1. Okay, so it pulls in and then etc. So if I right click on this transform tool here, go to actions, create reference copy. It creates another copy with exactly identical values. So I'm going to click on this translate and -1 multiplied by that. Okay, so it just does it on the opposite direction. Right, there you go. So we have 2 boxes pulling the sphere apart now. All right, perfect. I'm going to create a merge. Okay. And I'm going to pull these down a little bit. This off actually. These down. Oops. These down a little. Okay, good. In fact, this as well. All right. I'm going to create group create. Connect it there. Connect this one up here. And this one, we'll change it to points. And we will name the group pinned. And uncheck base group. Keep in bounding regions, bounding object. Okay, so if I select that, we should get some points. Alright, good. Now I'm going to put in a vellum attached to geometry right there. Okay, connected that. And I'm going to connect the third input of tetrahedral constraints to merge. So the group is connected, the group is created and connected to the first input, but the actual collision objects connected to the third input, okay? Because this is the collision geometry, all right? So let's check it out. Okay, I'm going to run this and I'm going to come back, all right? Enable the sim first. Okay, so I've ran through the sim here, so check it out. So that's how it looks like, all right? So I already know that there is a problem here, all right? So a couple of problems. One is I just want to check what's going on here, all right? So if I look at these boxes, so they pull out and then come back in. Yeah, that looks good. That's fine. And here in Vellum attached geometry, I haven't really specified what group I need to look at, all right? So if I change this to points, I need to select the pinned group, okay? Because it's important. If not, it'll just try and attach everything to it. So that's that. So I ran a little bit more, and there you go. So that looks a lot like how I expected to, all right? So there you go. One more time. All right, perfect. So that looks good now. Let's move on. So if I scroll through, you can see it's already breaking, okay? I mean, it's not really, but it is kind of breaking, okay? So what I'm going to do is I'm going to go inside of Vellum Solver. I'm going to put in Vellum Constraints and connect it to the output. Change the create constraints to each frame, constraint type to glue, and then I'm going to change nothing else apart from enable breaking and change the type to stretch distance. Now, if you leave it at stretch stress, it'll break, but I found it hard to control. So stretch distance was a better way, and distance threshold is the one which can, which you can manipulate and change how it breaks, right? Obviously. Okay, let's go check it out. Everything is default, by the way, if you remember, apart from the type and enabling the breaking, all right? So let me save it, and I'm just going to run this through now. Okay, I simmed the 3 frames now, so let me just run it for you. There you go. It looks significantly different. Previously, it was falling apart even at this point. Now it's sticking. And let me show you how that is, okay? So if I go inside, actually I can't, can I? I don't know. Can I visualize? Okay, I'll show you the other way, all right? So previously I was saying that I want to show you the Autodoc network way and the reason behind it. So I'm going to put in a doc network. I'm going to call in meet sim, I guess, whatever. I'm going to change this to meet sim. And I'm going to go inside Autodoc network. And I'm going to copy the whole lot here and paste it inside. All right, good. And obviously you need to change the source. So it's not sphere 1. In fact, it's Vellum meet geometry. And I'm going to copy this path and paste it here. Okay, so that's about it really. And all we need to do now is add the Vellum constraint, which we added in inside of the Vellum solver itself. Okay. All right, so I'm going to change this to glue. Create constraints on each frame, and then enable breaking. Change the breaking type to stretch distance. That's it. Nothing else has changed. Everything is the same. And I want to mention one more thing, right? So if you look at the sub-steps, I left it at 1. If you change this to 5 or something, you'll get more stability. However, you will see some jumping, okay? So I'm going to leave it at 1 for now, but you can play around with that, all right? It's the same with the sub-steps in here. It's exactly the same, identical. Right, I'm going to run this .NET sim, and I'm going to come back. Okay, I've simmed it for a little bit, and here it is. It's pretty much identical, all right? So I'm going to go outside. I'm going to put in a switch. Come on. Switch. I'm going to connect these two. And there's your output from Vellum Solver. And that's your output from MeetSim, all right? Which is the .NET. I'm going to put in normal. That looks weird. There you go. So 0 and 1. The sim itself looks significantly different, and I'm not sure why that is when all of the settings are the same between the two. But hey, anyway, that's the way it works. All right. But using .NET, the reason why I'm using .NET is because if I go into escape, get out. All right, if I go into this output that the shelf tool created for us, you've got your import geometry, and then you've got your import constraints. Okay. Now I want to use this import constraints to create strings later on, and I don't know how to get that out of the Vellum Solver itself. So if I look at null, if I put in a null, connect this to constraints, you get this, all right? But that's not good enough, because if you look at this one, if I connect it to that, where is it? Okay, in fact, I'll show you the other way. If I go inside and go into Vellum Object, where is this thing? There you go. I will uncheck display geometry for initial geometry, and I will check it for initial constraints. You see these little stitches? That, I don't know how to get that out of the Vellum Solver direct, okay? And that's what we need. But you don't need to, but you know, it'll be good if everything adds to the sim, all right? The only reason why I use the .NET is to create strings out of the constraints, okay? Again, you know, it's up to you. All right, so that's that. I'm going to change this to flat shaded because it looks much cooler when I run it, and I'm going to continue using the .NET. All right. So there you go. That's how it looks. Sweet. I mean, you may be wondering how it's done so easily, but the thing is, now, I mean, I've experimented this for a number of hours and days. So if I were to connect this, let's say without the material fracture, and if I now run this, okay, you will see that it's, where is it? Huh, it's not even there. Okay, what's going on? What's going on? That's because of this. That's fine. I'm going to just disable these two. And yeah, there you go. So, okay. So yeah, there you go. That's how it looks without prefracturing. I mean, if you know how to do it without prefracturing and doing the fracture on the go, then of course that's better. But this way I can art direct how I want to break it. Obviously we haven't really spent a lot of time on the material fracture, but you can, of course, and we will later on. I'm right now trying to set up everything so we can get the sim right and then move on. All right, so here's how it looks. Oops. Okay, I'll run it and I will save this and I'll come back to you. Okay. Okay, the sim is now done, so check it out, right? So that's how it looks right now, okay? I think it looks pretty cool. I just want to show you something that I forgot to mention, right? So if I go inside of .NET, I will change this threshold to 1, let's say, okay, from 0.1. That's significantly stronger. I'm going to run this and then come back to you. So here's the sim with breaking threshold set to 1, okay? So check it out. It doesn't break that easy, alright? Which is what you expect to see. So at frame number 72 with threshold 1, it's like this. And the same frame number 72 with threshold of 0.1, it looks like that, right? So you can see the difference between the two. There you go. So that's significant, all right? I just wanted to show you that, right? Okay, so that's good. Let's move on. So the point is that now I want to use this output that we got out of creating the .NET using the shelf tool, right? So I'm just going to copy these elements and I'm going to paste them all here. All right, so if I look at that, that's still pointing towards the .NET. I don't want that. So I'm going to point it to this midsim. And I'm going to copy that, change this one. Everything else should just work, okay? So there you go. That's working fine. And import constraints, it's the same. I'm change this to midsim. And I'm going to put this one here as well. So that should just work. There you go. That's showing up now, as a matter of fact. That's good. Before I forget, I just want to change this back to 0.1. In fact, the number that really worked for me, which I really liked, was 0.08. So I'm just going to punch that in already. Okay. So that's that Vellum post process. You can change the subdivision if you want. I didn't do that really, but we'll check it out now. Okay, I'll just let it run and I'll come back to you. Okay, so if I zoom in, so this is with subdivision and this is without. I don't really see much of a difference, to be honest. So I guess it doesn't matter. I'm just gonna leave it as it is and uncheck this apply welds. And I say that, okay, maybe I'll explain it later, but apply welds, what it does is it tries to weld the parts that are broken by creating a string or connecting the 2 points. Now, if you leave that on and if you enable shipping in RBD material fracture here, which we will later on, what will happen is you will have a bunch of very small parts which may actually detach itself and fall down, which is expected. But this weld thing will try and keep it connected, all right? So that's why I'm saying uncheck apply welds. All right, so here, that's the output. So I'm just gonna call this out. And this is the first part done, okay? So, I say first part because I'm gonna delete all this. All right, there you go, done. So I'm saying first part because we're going to create, I'm going to put in a, let's see, Vellum strings, and then we will create Vellum fur, and then we will create Vellum blood, and then we will do rendering, where we'll be creating material for meat, strings. Strings not that big of a deal, really. Fur, and then blood. Okay, all rendered in Redshift. Okay, so stay with me. Let's go to part 2.